So, it's time for finals again. 3 sleepless nights of cramming for that exam, and your body feels like it's burning out. Probably should have had more to eat than that Red Bull and Easy Mac. You wake up from that 30-minute nap you started 2 hours ago, and boom. Coughing, sniffling, you're sick.
Oh, who am I kidding, Gary? I've got the suds, no doubt about it.
But why do you really feel like crap? I mean, sure, your immune system will respond to a pathogen in certain ways, and logically they make sense. After all, it favors your body's way to try and fry out an invading threat, but what about the other stuff? Why do you get cranky and tired and sore? And why do you lose your appetite for anything other than Mom's Magic Soup and those vitamin C packets from CVS? These changes to the way you act are collectively called sickness behavior, and as it turns out, you probably have millions of years of evolution to thank. When animals get sick, we have this tendency toward antisocial actions. After all, walking around outside while you're weakened by an infection is a great way to end up dead via predator. There's also something to be said about curling up and taking a nap. By conserving energy, your body has a better chance of fighting off an infection. But hold on. Avoiding food puts an animal at risk for starvation. Social disinterest leads to decreased parental care, and a lowered sex drive makes your odds of passing on genes drop too. For these traits to be selected for over time, they've got to confer some advantage we haven't seen yet. One leading theory turns toward a genetic concept called kin altruism. If some trait gives enough of an advantage to a relative to outweigh the drawbacks to the individual, it can be passed on. Because this relies on shared genes between the individual and the recipient of the behavior, it helps to be as closely related as possible to better favor the gene. Let's look a bit closer at what exactly causes our behavior to change when we're sick. When our immune system detects an infection, chemical signals called cytokines are sent through your blood to recruit help. While the specific roles of each signaling molecule are not important for this video, the increase in general has a very interesting effect on the brain. So, whether or not a person is actually sick, an increase in cytokine levels can influence the brain's behavioral response. In one study performed in 1995, researchers gave subjects a known immune system stimulus alongside an artificial sweetener called saccharin. Saccharin is usually seen as benign by the immune system, but when researchers later applied only the saccharin without the cytokine, the same response occurred. So at the very least, the study does show that cytokine levels can play a direct role in affecting how we act and feel. So what would happen if someone were to have some abnormality that increased their blood cytokine levels? Even if their immune system was safe from infection, they might exhibit sickness behavior. This exact concern comes with a new way to look at one particularly nasty disease: depression. Looking at these symptoms, there are a lot of pretty striking similarities. Inhibition of social behavior, anxiety, focus issues, and anhedonia are all classic traits associated with sickness behavior. One 2012 study comparing the two found that both sickness behavior and depression involved a measurable spike in pro-inflammatory cytokines. Infection that initially provoked beneficial sickness behavior in some cases led to a positive feedback loop of neuroinflammation and neurodegeneration in others. We're still in the early stages of understanding this mechanism, but even so, by studying the link between behavioral changes in the immune system, we could learn new and exciting methods of treatment for the future. So, the next time you feel like garbage after some kid sneezes on you in a plane, just take a minute to think about why you feel the way you do.